Students, in this module, we would be talking about the real-life examples of non-parametric data sets onto which we can apply those formal tests. And further, we would be talking about the comparison of the parametric and non-parametric procedures, that in which type of data sets, if you are going to apply the parametric test, for instance, and some of the assumptions are not met, then what is the possible alternative available in the non-parametric statistical approaches. Students, if we just look at this comparison chart, that is giving us a clear picture of that comparison of the tests, parametric and the non-parametric. So if certain assumptions are not fulfilled with the parametric test, so we can look for certain alternatives of those parametric tests. For example, if we are talking about one sample t-test, so this is the one sample t-test. If one sample t-test is not, the assumptions of this test are not satisfied with certain data, then we have the possible alternative in the non-parametric test that is known as the Wilcoxon rank sum test. Similarly, we are talking about two sample case and the samples are independent in nature. Again, if certain assumptions are not met or the data is not completely available for that matter, or the sample size is small, normality assumptions are not fulfilled, then we have the alternative approach in the non-parametric statistics that is named as Wilcoxon rank sum test for two sample case. And students, you will find in certain texts it is being written as Mann-Whitney-U test, because Wilcoxon was the person who had first developed it, and later on Mann and Whitney, they have given that version of Wilcoxon rank sum test. If we talk about two paired sample case where two samples are in form of the pairs, or we call them as matching samples, again if certain assumption or even one of the assumption is not met, we will go for the alternative non-parametric approach. That test is known as Wilcoxon signed rank test. If we just move on and we talk about equality of several samples, and we would have to test the equality of several means, and all the samples are being taken, they are being drawn from independent populations. So that approach in statistics is known as analysis of variance, which is used to test the equality of several means. Again, if, for instance, your sample is not random, the assumption of normality is not met with your data, then you will have to go for the non-parametric test. For that matter, it is Koskalwallis test. And under that one-way ANOVA, if the samples are matching sample or they are the repeated samples, for instance, and some assumptions are not met again with that data, then you can go for Freeman or the Friedman test. And finally, if we would have to test the relationship between two data sets, we can employ the Pearson correlation test. Again, if the assumptions of the test are not met, for example, the basic requirement is that the two variables must be quantitative in nature. So even if one of the variable is not quantitative, we can't apply Pearson correlation test. And for that matter, we will have to go for the non-parametric alternative that is known as Spearman's rank correlation test. So students, next I'm going to take up certain examples, real-life examples of the data sets that we can use under those non-parametric tests. So students, पहली example हम लेंगे sign test की. Let me read that example for you. For a data about component lifetime in hours, test that the median lifetime exceeds 25 hours. So सबसे पहले आप देखिए कि यहाँ पे lifetime in hours की बात की गई है. So lifetime in hours, usually it is a quantitative phenomenon which is being measured on a continuous scale. So इसमें जो टेस्टिंग पे अगर आप गौर कीजिए स्टूडेंट्स, मीडियन को टेस्ट करने जा रहे हैं. So we are not talking about mean for that matter. So जब भी आप मीडियन को टेस्ट करेंगे और आपकी पैरामेट्रिक assumptions कुछ फुलफिल नहीं हो रही हैं आपके डाटा के साथ, तो हम सिंगल मीडियन को टेस्ट करेंगे using the sign test. Let us have a look at its assumptions. Data must be ordinal or it has to be continuous, and there is no underlying assumption as far as the distribution of the data is concerned. Now moving on to the two population case, where we would have to test the equality of the two medians, and the samples are being taken as independent samples. So let us take its example, students. Age at diagnosis of type 2 diabetes in young adults has been recorded to observe whether the age at diagnosis that differ for males and females. Again, they are two independent samples, and if we would have to test the median of two types of data sets in order to test the diagnosis of type 2 diabetes, so that will be achieved through Wilcoxon rank-sum test, जिसको students हम Mann-Whitney test भी कहते हैं. But before applying the test, we would have to look into the assumptions of this test. The sample has to be random. The next assumption is that the samples are the independent measurements from the population. So आपने अभी example में देखा कि हम male और female data sets की बात कर रहे थे. So they are being independently drawn from populations, different populations. And lastly, the variables has to be ordinal or continuous. Again, it is met with this particular statement. So we can apply the Wilcoxon rank-sum test on this data. The next example is about the paired samples. So let me read that example for you. A total of 15 patients with pre-hypertension enroll in the study, and their systolic blood pressures are to be measured. Each patient then participate in an exercise training program where they learn proper techniques and execution of a series of exercises. Patients are instructed to do the exercise program 3 times per week for consecutive 6 weeks. After 6 weeks, systolic blood pressures are again measured to see that is there any difference between the systolic blood pressures after participating in the exercise program as compared to before. अब स्टूडेंट्स इधर आप देखिए सिर्फ नंबर ऑफ पेशेंट्स आर द सेम, वही 15 पेशेंट्स हैं, उनके बिफोर एक्सरसाइज मीडियन एंड आफ्टर एक्सरसाइज मीडियन को आप मेजर करेंगे एंड यू वुड बी making a comparison between the two, that whether the exercise would have certain effect onto the systolic blood pressure. अब स्टूडेंट्स इस डाटा के ऊपर, क्योंकि हम मीडियंस को टेस्ट कर रहे हैं, क्वालिटी ऑफ 2 मीडियंस और पेड सैंपल है, so we'll be applying Wilcoxon sign rank test. Let us also look at the assumptions of this test. The assumptions are very few, students. Data must be in pairs and is drawn from the same population. The next assumption is that each pair is selected randomly. And finally, the variables are measured at least on interval scale. So these are the few assumptions about the data which usually are being followed onto certain data sets. And finally, we are talking about testing of equality of several population medians where the samples are independent. Students will be applying the Koskalwallis Test. Let us follow the example. A study is conducted to test the effect of exercise on depression. Individuals who were tested for the depression were randomly assigned to 3 groups. The first group with no exercise, the second with 20 minutes of jogging per day, and the last group who followed 60 minutes of jogging per day. At the end of the month, they were asked to rate that how depressed they feel now. So the level of depression is to be measured for all the 3 groups. So for that matter, we'll be applying the Koskalwallis Test if we take into account the medians of 3 data sets. So let us, students, quickly, we would have to look into the assumptions before applying the test. The independent variables are required with 3 or more levels. As in case of this particular data set, we have 3 levels. The one group with no exercise, 20 minutes of jogging, the other group, and then the 60 minutes of jogging, the third level. And the dependent variable should be measured on ordinal, ratio, or interval scale of measurement. So as you can see that the level of depression that is being calculated in form of the scores, which are quantitative in nature. So students, so far we have learned that how onto different real life data sets we can apply and we can see the appropriateness of various non-parametric tests.